Perfect. All right, so let me start with this slide. So we're going to talk about teaching real science to kids today, the why and how to introduce real science to elementary students. And before I jump in and talk about that, though, I want to talk a little bit about childhood dreams and failed expectations. So I've been thinking about and developing curriculum for almost 20 years. And I've been thinking a lot about not just how to teach science to kids, but how kids learn. And it's not uncommon for me to meet parents or teachers or other educators who have given up their childhood dreams of becoming a pharmacist or a molecular biologist or an engineer. And when I go to conferences, I meet a lot of people who tell me, I just didn't have what it takes to do the kind of science that I needed to do to be a pharmacist or an engineer. I couldn't hack. I didn't have what I needed to do the chemistry and physics. And when I think about my own journey, this was almost true of me. I grew up in small New Mexico City, and I dreamed of becoming a scientist. But when I went to college, I actually failed my first chemistry exam. I failed it pretty miserably. I got a 37% on it. And the truth is I felt woefully unprepared for college level science. I, didn't have the background or the basic building blocks that I needed to handle college level science classes. And even though I was a straight A student in high school, I graduated third in my class, and I took all of the advanced classes I could take. I took chemistry, I took advanced science, I took advanced math, and still I wasn't prepared for college level science. Well, I did make it through that year of freshman chemistry, and the thing that I did was befriend a girl. Her name was Arlene, and she had come from Los Alamos. And it wasn't until years later when I was thinking about how can I educate my own kids, how can I teach them science, that I actually stumbled on what I think is a key reason students struggle, especially in high school and college. And the reason that students struggle, one of the reasons that students struggle, is that the curriculum that's provided for students and for educators tends to approach science in what I call the random fact approach. So the random fact approach to science education is really just what it says. So these I've got on the display here on the screen here. I've got a couple of different textbook pages, and these are the table of contents from a couple of different California science textbooks. And if you look at them, you know what? I'm going to switch the mode here to see if I can do something a little different. Can you see this?
Uh-huh.
Is that, does it show all the rest of the slides? Or are you seeing just this?
It shows the slides along the bottom.
All right, how about that?
Yeah, perfect. There you go.
Okay, let's do this. I was thinking that maybe I hadn't had it in the right format. Okay, so let's take a look at these three table of contents. What you can see is there's a set of random facts, right? There's plants and their needs, animals and their needs, and then that skips to weather and seasons for earth science, physical science, solids, liquids, and gases, and so on. Okay, so you can see in grade 1, grade 2, and grade 3, there's just these sort of random sampling of what I would call scientific topics. And so if you think about it, to me, when I was looking at science textbooks after I had gotten my doctorate and after I started thinking about how to teach kids my science, how to teach my own kids science. And it seems like this random fact approach is very similar to the junk drawer in your kitchen, right? So I have a junk drawer in my kitchen. And if you think about your junk drawer in the kitchen, it's got all these random things in it, right? You may have some scissors, you might have some rubber bands, might have a paper clip or two, but it's random in there. It's just thrown in there. When I was educating my kids, I also had an office drawer, right? So I do have an office drawer today. And in the office drawer, everything is organized, right? And one of the things that I observed with myself and with my children is that when you really need to go find something, do you go to the junk drawer or do you go to the office drawer? Well, if you really in a hurry and you need the paperclip or you need those scissors right away, I tend to go to the office drawer. Why? Because it's organized. It's got its own particular place. It's organized. It's easy to retrieve. I remember where it is, and it's easy for me to pull out. And that's true, not true of the junk drawer. The junk drawer is all this random stuff. I might take 10 or 15 minutes to look for something that may or may not even be there. So this got me thinking about, okay, curricular materials tend to approach science from this random fact approach. And even today, the next generation science standards do the same. If you look at the next generation science standards, there's just these random factoids, a little bit of, physics, a little bit of chemistry here or there, a little bit of earth science there, a little bit of biology here. But it isn't actually the way people learn. So as I was developing curriculum, I stumbled across this book. This is actually a photograph of the book that I own, sitting on my countertop. But how people learn is different than basically there's a number of different aspects to how people learn that isn't found in your traditional elementary and mid-school science books. So if you read this book, so this book is a pretty common book if you're going to be applying for like educational grants and stuff. I think it's pretty common in educational circles. And one of the things that these folks found out is that to develop a competency in any subject, there's three main components. The first is students need to have a deep foundation of factual knowledge. The second is students need to understand facts in a contextual framework, facts and ideas in the context of a conceptual framework. And three, it's easier for students to understand and retrieve information if that information is organized in ways that facilitate retrieval and application. So in other words, if things are organized, if there's a deep foundation of factual knowledge, if they can understand facts and ideas in this framework, and if that knowledge is organized in ways that help facilitate retrieval, then people learn, kids learn, even adults learn. So this got me thinking about how do we teach, how do we create environments for students to learn science. And so back in the day when I was developing curriculum, I was on the framework committee for revising the New Mexico State Science Standards. And I had the opportunity to talk to a variety of elementary students or teachers who teach elementary students. I was on the framework committee for the elementary grades. And I asked a number of elementary teachers, so why not teach atoms and molecules and chemical reactions to first graders? Well, there's a number of challenges that elementary educators face when it comes to teaching what I call real science. And the first is defining science. The second is understanding their own understanding of science or exploring their own understanding of science. And third, understanding or exploring their students' understanding of science, okay? And finally, you do have to make time to make science happen in the classroom. So there's a time limit as well. So these are four basic challenges that elementary educators have when it comes to teaching real science. So I want us to do a little breakout room here with everyone. So this would be a breakout. And what I'd like you guys to do is define what is science, okay? I want you to think about what science is. I'd like you to think about your own understanding of science. And I'd like you to think about where you feel challenged in that area and why, and what kind of feelings come up for you. Like, okay, I'm defining science and you know what, or I'm going to have to teach science. So what comes up for you when you think about your own understanding of science and how easy or difficult it is to define science? And the third piece is I want you to think about your students' understanding of science. How well do you know, what ranges of understanding do your students have when it comes to science? So let's do a little 5 to 7 minute breakout here. talking about what is science. And I'd like you guys to communicate with each other, explore the definition of science, explore and how you feel about defining science and how well equipped you feel you're able to do that. Okay?
All right, here we go.
So let's dive in. So, okay, so what is science? We looked at, I talked to Nicole and Deanna about defining science. And I also we talked about what comes up when teachers who feel like maybe we don't have enough background for teaching science, when we're required to teach science, when educators are tired, I haven't had any science classes, or I didn't take the upper level. Nicole says she didn't take the upper level science classes because she didn't really like them and maybe felt like she didn't understand them and it really wasn't her main thing. So the question was defining what is science. Now, when I was starting to think about the difference between what I saw in the elementary textbooks and what I actually used as a scientist, okay? So there's a difference between what's taught, this random fact approach, in the elementary and middle school textbooks, and what kids actually see in high school and college level classes. And so real science, I'm going to define for you what I think real science is. Real science is the science that scientists actually use, okay? So there's a lot of science out there that you can go online, you can look up a definition of science, and I'll bet you're going to come up with 100 different definitions of science. But real science, and the kind of science that we want to teach students, is the science that scientists actually use, and that's atoms and molecules and chemical reactions, right? How many elementary grade textbooks do you know that talk about atoms and molecules and chemical reactions? Not many. Force, energy, work, that's physics, inertia. Proteins, DNA, cells, energy systems, taxonomy, gravity, astronomical units, parsecs, telescopes, minerals, soils, waves, plate tectonics, right? Geospheres, biosphere, and a lot of math. This is the kind of science that scientists actually use. And the problem is, and what I sort of decided to switch up, is that in the elementary and mid-school grades, none of this is introduced, okay? None of these topics are introduced until high school and college. And you can look at testing scores. You know, if you look at the tests for grades 4 versus grades 8 versus grades 12, they start to plummet in grade 8 and plummet even further in grade 12 when it comes to science subjects. And the reason is that there's no foundation, the basic building blocks of science are not actually getting taught. They're not getting presented to students. And this is one of the things that I launched into heavily. I started thinking about, how do we get kids to learn science? Well, in my opinion, it's no different than getting a child to learn a language or getting a child to learn music, right? When we're teaching a child a language, what do we teach? What do we start with? Well, we start with the alphabet, right? We teach them the alphabet. We teach them the sounds that the letters of the alphabet make. We teach them how those sounds get put together to make words, words put together to make paragraphs or sentences, sentences to paragraphs, paragraphs to novels, and so on, right? We don't not give kids any of the basic building blocks of language and then dump them into a Shakespeare class, right? And try to get them to understand what the heck Shakespeare's even saying, right? Because you have to have the foundational pieces of language to understand higher level materials. The same is true with science. You need to have the foundational pieces, atoms, molecules, chemical reactions, in the elementary, starting in first grade, building on that foundation, and in an organized manner, so you don't have the random fact approach, you start to teach kids science the way that scientists learn and ultimately use science. It's organized, okay? So this is why real science is not taught generally in the elementary grades, right? Textbooks generally don't present real science in the elementary grades. Elementary school teachers can feel intimidated by real science, having not actually been taught much of it themselves. And so that's what we explored in the breakout room. I was talking to Nicole. It's like, well, I haven't had a lot of this science. So how can I teach it? You know, and Nicole's looking online, going to Google searches so she can try to explain the science to her kids. The other thing that I ran into when I started developing curriculum that would give kids the basic building blocks for science is there were a lot of educators who believe it's too hard for young students to understand, partly because they don't understand it, right? They weren't taught the basic building blocks. And I can tell you for sure that if somebody told me, you know, I had to teach music. I'm not very musical. I don't know music. But if somebody said, you know, I have to teach somebody the Moonlight Sonata, I would say, well, that's too difficult for a child to learn the Moonlight Sonata because I don't know how to play it, right? But I know that you start kids with elementary, you know, they learn about the notes. They learn about how notes fit together to make, you know, music and so on. So many educators believe that it's too hard for young students to understand. And so what happens is that in the elementary and mid-school grades, what I call real science gets completely avoided. You get this random fact approach in our textbooks. And by the time kids get to high school and college, they're unprepared for real science classes like I was. You know, as it turns out, you know, I used to think Arlene was just a very gifted, you know, and smarter than me student, but it turns out that she grew up in Los Alamos, and then the kids in Los Alamos start having real science in the elementary and mid-school grades. Why? Because their parents demanded. So that brings me to this next, we're going to switch gears a little bit, and it brings me to the next piece that I want to talk about. And that is maybe we have how to teach real science to students all wrong. So over the last couple of years, I've been very interested in, so the first 20 years, I basically developed curriculum to get these basic, the foundational building blocks of science put in textbooks. And the last 5 to 10 years, I've been thinking about how does somebody actually learn? Not just how do I teach it, but how does somebody actually learn? And there's a lot of research out there about student-directed, question-focused learning environments. So if you create a student-directed, and we're gonna go over this in detail, we're actually gonna do this as an exercise, student-directed, question-focused learning environment, kids learn much faster, they retain more information, and they recall the subject matter better than students taught in other teaching environments, okay? The second piece to note is that teachers, if you create this kind of a learning environment, teachers need not be experts in science. All right, I'm going to say that again. You don't have to be an expert in science. You simply need to have the right tools to create and facilitate the right learning environment. So we're going to practice a question-focused activity. That's what we're going to do. And I'm going to show you where you don't need to be the expert in science. So I spent the first part of my career building science curriculum teaching homeschool parents who don't have any background in science education, haven't taken any high-level science classes, how to teach their kids science. And basically, you just flip it. You let the kids ask the questions. The last piece of this is the textbooks and educational materials are really there to provide the framework, the organization and context for learning real science. And they serve as a launching pad for students to dive deeper. So the curriculum material that you use is important in helping create this learning environment and helping kids start to launch into this question-focused activity. Okay, so the elements of a successful learning environment. Let's talk a little bit about some of the elements of this learning environment. The first is print versus digital. Okay, so there's a lot of studies that talk about print versus digital when it comes to learning and memory. And right now, particularly with COVID happening, everybody's moved to digital platforms. And I'm going to say that I'm not, there's a place for digital platforms, but I also want to emphasize that print material is actually better for kids and adults when it comes to learning and absorbing more information. So I don't know if any of you guys have read this book by Nicholas Carr on the Shallows. It's a really great book that talks about what the internet is doing to our brains. And when it comes to information delivery, print is actually superior to digital. So many studies show that students of all ages absorb more when they're reading on paper than when they read on screens. And there's a lot of different reasons for that. One reason is that when you read a textbook, when you read any kind of book, you actually remember better because your brain looks for landmarks. It looks for the margins, it looks for how thick the textbook is, it looks for the size of the book. So there's a lot of different landmarks that happen with print matter that don't happen or can't happen with the digital platform. But digital platforms are great for things like this, Zoom, and they're great for doing research. And I'll talk a little bit more about that in a minute. So the second piece to creating a successful learning environment is an active versus passive instruction. And it's all about who asks the questions. Okay, so the traditional model, the model that we've been using for the last 100 years is kids go to school, teachers give lectures, kids take notes, teachers hand out homework assignments. And it's still all about the teacher asking the questions, okay? It's not about the children asking or the students asking their own questions. And I've been really interested in this over the last couple of years because when you can ask your own questions, you are actually more interested in what you're learning. So there's a great book, and if you have a chance, I would highly recommend purchasing it. It's called Make Just One Change. It's by Dan Rothstein and Lou Santana, and it's from the Harvard Education Press. And it's written by it's from the Right Question Institute. So if you go to the rightquestioninstitute.org, you can find this information. And I took a little Harvard workshop, online workshop, to understand a little bit more about what they're doing. And this is the activity we're actually gonna practice today. But even homework is passive instruction, okay? Lectures are passive, homework is passive because it's the teacher or instructor or curriculum provider that's asking the questions. Active instruction is more about letting the students ask their own questions. All right, hands-on activities versus demonstrations. I think probably many of you are already familiar with this, but hands-on activities are superior to just demonstrations. So students who physically experience scientific concepts understand them more deeply and score better on science tests. So you've got to get kids doing hands-on activities. A lot of times when teachers are pressed for time, I remember this happening all the time in my college level classes, is there were a lot of cool demonstrations, you know, mixing things and having things blow up. And, you know, I was very interested in luminescence at the time. And so there was, you know, anybody who was doing a luminescent experiment was really, it was interesting for me. But kids and adults learn more with hands-on activities versus just demonstrations. And the last piece is collaborative learning. So when I was in school, basically there wasn't any option for collaborative learning because teachers didn't want you cheating. But you know, you listened to a lecture, you took notes, you went home, you did your homework, and you didn't really work with anyone else. And you didn't actually, I never really got the opportunity as a child to present what I thought I'd learned to anybody else other than on an exam, right? Which is again, the teacher asking me their questions. But as it turns out, collaborative learning, if you all know that if you have to teach somebody something, if you are learning something, but you have to turn around and teach somebody else what you're learning, you learn it much, much better. You learn it much more deeply. So collaborative learning is an essential piece of getting kids to you know, function in a successful learning environment. Okay, so in summary, and we're gonna jump to our exercise in just a second. Educators only need to create and facilitate a successful learning environment and need not be experts in science. If you only take that away from this topic, this workshop, that's the one I'd like you to take. You don't have to be an expert in science. I believe students need to read print books with real science terms and concepts. That's superior to information delivery from a digital platform. Students need to be actively instructed with student-directed, question-focused activities rather than passively lectured to and assigned homework. So think very carefully about the difference between passive instruction and active instruction. It's not that homework is bad, and it's not that ultimately testing is wrong. It's just that I think the focus should be on active education or active activities rather than passively lectured to and assigned homework. Students need to participate in real hands-on activities and not only watch demonstrations. And finally, students need to engage in collaborative projects and student sharing within classroom, schools, and internationally. So that is the bulk of what I wanted to say. So next piece is I want to go ahead and try it. So what we're going to do is we're going to, I'm going to share a different part of my screen. And so I'm going to do a new share. What we're going to do is we're going to read a reader together. Okay. We're going to read, we're going to do this. Now, if I had it my way, I'd have all of you have your own print book in front of you. It's not that digital platforms are all bad. Sometimes you can't get away from it. And so we're going to look at this reader together. So this is a little reader. We've been working on these readers for grades 2 through 5. And we're going to learn about what is chemistry. And then after we do the reader, we're going to launch into an experiment where we do a little hands-on activity. Okay? Chemistry every day. So let's look at the reader first. So imagine you're sitting in a classroom, and if you can imagine yourself as a teacher, maybe you have a couple of books handy for your students, but let's read what is chemistry. So what is chemistry? Well, chemistry is a branch of science. Scientists who study chemistry are called chemists. Chemists want to know what the world is made of. You can see over here this guy thinking about, I wonder what the world is made of. You've got a little mouse here saying me too. Smells good, says the alchemist. The first chemists were called alchemists. Alchemists cooked metals, liquids, and dirt. Alchemists did this to make new things. You can see this mouse, he never cooks. He just eats cheese. Greek alchemists tried to turn lead into gold. They wanted to get rich. Presto changeo, turn to gold. Chinese alchemists tried to make gold very pure. They thought pure gold would help them live forever. Not a bad idea. Chemistry happens all around the world. I wonder what kind of chemistry is happening. We can make a snow mouse. You use chemistry every day. Chemistry happens in your tummy when you take medicine. Chemistry happens when you paint with watercolors. Chemistry happens when you brush your teeth. Chemistry happens everywhere. Chemists use chemistry to help us understand the world. And then here is a little glossary, how to say science words: alchemist, chemist, chemistry, liquid, medicine, science, scientist. Okay, so this little reader is a way to deliver factual content, okay, to students. It's short. This is for grades 2 through 5. It's short, but it has actual content in there. It talks about chemistry and chemists and alchemists and what chemistry is. It defines chemistry for students. So after reading the reader, the next piece is to launch into the question-focused activity that I talked about. So we're going to do a question-focused activity. So we're going to do this part of it together. So what questions do you have about chemistry? So if you have the handout handy, you can go ahead and use it. But if you don't, grab a piece of paper, and we're going to look at part 1 right here. Okay? So this is the question-focused activity where we're going to ask questions about chemistry. And what I want you to do is put your, little 2 to 5 grade level thinking cap on, and imagine that you're a small child in this classroom, or even you can ask just as an adult, maybe you don't know a lot about chemistry. what questions do you have about chemistry? So let's just take a couple of minutes to do this exercise. And I'm gonna go ahead and answer and ask my own questions about chemistry. And what you can do is think about what we looked at in the little book, right? So each one of these can be what's called a question focused prompt, right? It can springboard some questions. So maybe I'll give you an example of a question that I might ask by looking at this little girl brushing her teeth. So she's brushing her teeth with toothpaste. And the truth is I don't really like toothpaste. What kind of toothpaste, what is in toothpaste that makes it taste bad, right? That could be a question. What is in toothpaste, or what maybe could I put in toothpaste that could make it taste better, okay? So you can see there are all kinds of questions that pop up when we start thinking about chemistry, okay? So going back to the experiment, think about anything, any question you have about chemistry, and write 3 questions about chemistry. And I'm going to be quiet while I write my questions for just a couple minutes. Okay. So write 3 questions about chemistry. Does anybody want to write in the chat what some of their questions might be? And Melinda, I can't see the chat, so.
I can let you know too, Rebecca, if we see anything.
Okay. Yeah, so what are a couple of questions that you might have about chemistry? Now, I'm going to say something about asking questions. This is actually kind of hard to do. So if you're sitting there going, oh, I don't know, I don't want to ask any questions. One of the reasons it's hard to do is because we're not used to asking questions. We're used to answering questions, but we're not used to asking them, unless we're asking them on an exam for a student or something, right? There's a lot of trepidation that we feel when we have to ask our own questions, okay? And it's interesting that adults have much more difficulty asking questions than even young children do. I believe we educate it out of them by making them feel like asking a question, you have to have the right question, or you have to ask a good question.
Yeah, we're getting some good questions in the comments.
Yeah, good.
Mm-hmm. There's some, let's see. How are colors made? Why does medicine taste bad? Why do I have to brush my teeth? What is toothpaste?
Good.
What is in toothpaste that helps clean teeth? What is in color? How does medicine work? What happens if we mix color? What affects the way something tastes? What makes toothpaste foamy?
Right.
What happens in our mouth when toothpaste is introduced? Do we really need fluoride? Where do you find chemistry?
Yes, okay, those are great questions. Okay, good. So now what I want you to do is I want you to look at a couple of those questions, and I want you to switch them from an open-ended question to a closed-ended question. All right, an open-ended question is a question that doesn't have a yes or no answer, right? A closed-ended question has a yes or no answer. And the reason I'm asking you to do this is a really important part of the exercise. It gives students a way to evaluate their questions, and it gives them the understanding that the kind of questions we ask changes the kinds of answers we're going to get, all right? So an open-ended question, as you could imagine, gives you a very different kind of answer than a closed-ended question. So take a couple minutes and flip them from open to closed and closed to open. And let me know if you have any problems with that. And then write some of those in your chats. And Melinda, if you could tell me what they're writing, because I can't see it.
Yeah, I went ahead and put one in there. I just grabbed one. Someone wrote, "Why are eyes different colors?" Leslie did that. And so I changed that one and I said, "Are eyes different colors?" So that would be changing it to from an open to a closed.
Right.
So that's an example. And then let's see. We've got another one. Let's see. Does medicine taste bad or good? So that would be changing up. Well, I
Yeah.
was going to find the one that tied into, but that's
How
a
does
good.
medicine taste?
Mm-hmm.
Does medicine taste bad or good would change it from an open to a closed.
Right. Can you mix colors? Change. That's another one. Changed to a closed-ended. Another one. What about fluoride that is beneficial for tooth and mouth health?
Right. Okay, so practicing changing open to closed and closed to open. And I got to say, sometimes it's a little challenging even for me. Sometimes I look at a question and I'm like, oh, I'm not entirely sure. So every time, so one of the things that I learned is that learning happens on that line between frustration and boredom, right? So you have this line between frustration and boredom. You want to frustrate your students a little bit, but not too much. You don't want them to be, you want them to be a little bit bored because then their active imagination goes, but not too much, right? So sometimes switching open to close and closed to open can be a little challenging. But it sounds like a lot of you guys have already, have nailed it. So what I want you to do next is I want you to pick your favorite question. And what I mean by favorite is if you could, if you had the tools, if you had all the resources that you needed to answer that question, that's the question you would want most answered, right? So think about one of the questions you asked and it's the one that really inspires you. I was doing this on an online class and I asked the question, how many pieces of pie can an ant carry? Because it was a graphic in one of my books. It's like an ant carrying 2 pieces of pie. And I want to know, how many pieces of pie can an ant carry? That was my question. And then I did a little video to answer it. And it was just a calculation, right? So think about a question of yours that you're very interested in answering and then circle it. And we're going to save that one for later, okay? So just keep it in mind. All right, so let's move on. So this is kind of not going to apply because we don't have watercolors. So I'm going to skip the step, set up your experiment. But we're going to do an activity here. This is the hands-on activity that I was telling you about. So this is going to be more of a think about it, but it's going to be your thoughts, right? You're going to think about ways in which chemistry have been used. So this first part, the think about it part. So let's think about ways that people might have used chemistry. Think about whether or not the things people do in a day involve chemistry, what they do, where they go, what they eat, and so on. So you can think about making a list or drawing some photos of that, some drawings about that. And do you think any of these activities involve chemistry? Explain. So you can see here, I am asking questions. I am asking students to answer some questions. And so the question-focused activities you can include questions in them, right? And in the hands-on activity, you can as well. It's not that asking questions is all bad. It's just that the focus should be on student-directed question-focused activities. Okay, so now what I want to do with this next section is break into another breakout room. Okay, so 10 minutes for this breakout room where we're going to do this observe it part. So does everybody have the handout so that we can break out into breakout rooms? So we're going to observe it. I want you guys to think about what you did in the morning, what you will do at noontime, what you might do in the afternoon or evening, or you can even think about what you did yesterday and ask yourself, where have you used chemistry before? What you did, what you ate, anything that you can think of that involved chemistry. So let's take a few minutes in a breakout session and let's think about where we use chemistry, okay?
Rebecca, I have the breakout rooms ready to go. How long would you like them in the rooms?
Let's do this for, let's see, 5. I want the other one, the last one, to be longer. So let's do this for 5 minutes.
Okay.
All right, so for those of you guys are here, so what do you think about what kind of, what, you can write in the chats, what kind of chemistry did you guys discover you used every day? What were your thoughts on that? I was talking to Purvi, and pretty much everything she did involved some aspect of chemistry, right? So brushing teeth.
Oh, this is coming up. It looks like hand washing, cooking, baking, driving a car, running, exercising, making the latte in the morning, digesting food, makeup, washing dishes, asking nonstop questions. So like their 4-year-old asking nonstop questions all day.
Yeah, so there's lots of chemistry. So this little exercise is a way to, hang on, is a way to help kids and adults see that, we use chemistry every day. We use them, when we wash our hands, when we brush our teeth, when we make tea, right? So chemistry is not just something you study in high school and college. It's an everyday activity. We use chemistry all the time. And helping kids be aware that, everything we do pretty much involves chemistry. And then Purvi was talking about vacuuming, which also involves physics. So there's lots of questions that we can ask, that we can help kids, or kids can ask about the chemistry every day, right? What kinds of chemistry do they use? So let's go back to the handout. Are you guys still seeing my screen, by the way?
No.
No. Okay.
Not presently.
All right. Let me make sure, share my screen again. All right. So let's go back to this hands-on activity. So we observed all these different ways that we use chemistry every day. And it's kind of fun to think about all the different ways we use chemistry. So do you think you use chemistry when you brush your teeth with toothpaste? Can answer why or why not. Do you use chemistry when you cook food? Why or why not? Do you use chemistry when eating food? Yes. Why or why not? And so on. So you can have, we did answer all of these questions. So here's a little explanation as to why I think it's good to provide this. This is part of providing a framework, right? A lot of times we do an experiment, or we learn something, we do maybe a hands-on activity, but we don't really, provide the framework for it. So the why gives an answer or an explanation for why we saw what we saw. So chemistry is the study of physical things and what things are made of. Chemists are scientists who do experiments to find out what physical things are like and how they change. Experiments help chemists discover useful changes that happen to physical things. For example, chemists can find out how things can be mixed together to make a soap that will take stains out of clothes. Many daily activities use chemistry. Toothpaste is made of chemicals that help keep your teeth clean and gums healthy. Cooking changes the chemistry of food. Eggs solidify with heat because of chemistry. Your body uses chemistry to digest the food you eat. A car is powered by the chemistry of gasoline. Painting a picture involves making mixtures and using chemicals that give off particular colors. We use chemistry all day long. So that concludes the hands-on activity for this particular exercise. We're going to skip the just for fun because we don't have the watercolors. And we're going to jump to the last part of this, which is the collaborative part. So what I want to do in the last 10 minutes is we're going to do this let's play. So remember the question that I had you save at the beginning of this exercise. So think about your question, pull that question out. If you could answer that question, that's the question you would answer. And what I want to do is get into some groups, and I want you to think about how you could answer your favorite question. And then maybe together collectively pick one question that all of you would want to answer. So think about how you would answer your question, share it with your group, then collectively pick one of those questions and think about how you would answer it. Would you do an experiment? Would you do some research and then give a lecture? Would you create a play? Would you write a report? Would you do something else? Okay, so imagine, since we're not going to actually, we don't have time to actually answer these questions, I want you to just think about how you would answer it and what would you do if you could to teach somebody else how you answered this question, okay? So let's spend 10 minutes or so on the last question, the questions that you picked, your favorite questions. Talk about the questions within the group, maybe pick your favorite question and just sort of explore how you might answer that question, okay?
Okay, go ahead.
I think we had fun in our little group imagining what it would be like to answer these questions and then deliver them. So you guys can write in the chat like what your experience was about if you were going to answer your own questions, or if you got together as a group and picked a question that you wanted to answer. But one of the things that came out of our little breakout room is that it's really fun to ask and answer our own questions. In fact, it was great to talk to Purvi and Nicole and Andrea, because as they were explaining, we did a thought experiment. Okay, we've answered all the question, we've got all the details, and now they're going to do a presentation, and Purvi was going to do a lecture, and Andrea was going to do a series of drawings, and Jasmine was going to do visual aids with teeth brushing because she had a question about brushing teeth. But what was really exciting for me was to watch them explain how they would deliver the information of their question. In other words, how they would present to somebody else. They're excited. It's like, this is fun. And at the end of the day, they're going to learn so much more about why medicine tastes bad, or why gasoline moves a car, or why toothpaste, how does toothpaste clean, than they would if I lectured them, or if I had them read a book about it, or if I had them do a homework assignment. Why? Because it's their own questions, right? So that is really the nuts and bolts of what I wanted to say today and demonstrate for you guys. This question-focused activity, in summary, yes, we need to have factual knowledge. We need to help our kids find the factual knowledge they need to build that foundation. I believe that the right curricular materials can help that, but curricular materials in classrooms are only just the launching pad, right? They're just the starting point. They give kids some ideas about how the world works. And when it comes to science, giving kids ideas about atoms and molecules and chemical reactions and force and energy and work and inertia and all the things, all the real science that makes up real science, right? That real scientists study, is the place you want to launch them from, right? So not the random fact approach, but an organized way to introduce, factual material to students. But at the other side of that is getting kids to ask and answer their own questions. And this is by far, I think, the biggest message I want you guys to take home is that you don't have to be the expert. You really don't have to worry about answering your kids' questions. Sometimes it helps to give a little bit of an answer or direct, right? But if you can step back and be more like a graduate advisor, where they come to you with questions and you simply provide the resources for them to answer their own questions, they're going to be excited about science. They're going to be and this applies to any subject, can apply to history or literature or anything, but they're going to be more excited about what they're learning, and they're going to learn it at a much deeper level than they would from any lecture or any homework assignment you could give them. Okay? So that was really sort of the bulk of what I wanted to say to you.
Well, thank you so much, Rebecca.